available to you as we go through. I'd also like to send a vote of a hello from Tony Hill, who was hoping to actually be here. Some people have actually asked after him, but the chair of the Asia Pacific Task Force as well was hoping to be able to make it up here this week, but something came up and there's been a clash, so he hasn't been able to come. But welcome to Tony. He may be online, in which case, hello, Tony. This is just a general welcome first, and then we'll go through some of the presentations that we're going to do tonight. Then we'll hand over to the IPv6 Readiness Measurement BoF, and they'll manage their part of that agenda as we actually go through it. So I'd like to hand over just one more thing, a vote of thanks to APNIC for the support that they actually give the Asia Pacific Task Force, and for MIWA for the support that she gives us for the Secretariat as well. So thank you very much for that support, and enables us to continue our information exchange. So thank you. I'll just hand over to MIWA.
Okay, I'll give a very, very quick Asia-Pacific IPv6 Task Force Secretariat update. APIPv6 Task Force met at APRICOT 2014 February in Malaysia, in conjunction with APNIC 37 as well. We had a remote participation as well, and it was co-hosted with IPv6 Readiness Measurement BoF, which is led by a TWNIC colleagues. We had 18 presentations and about 100 participants. We are trying to still keep supporting the AP community with IPv6 deployment. Task Force is trying to share the IPv6 deployment stories with community members, and IPv6 Readiness Measurement BoF try to share the IPv6 readiness actual statistics with community members. Next meeting, this meeting is actually at APNIC 38. We are having now again co-hosting with IPv6 Readiness Measurement BoF. So next meeting we'll have is in conjunction with APRICOT 2015 in Fukuoka, Japan. So date and details hasn't been decided yet, but please pay attention for the future announcement. And if you have any interesting topics to share through the IPv6 Task Force and also the IPv6 Readiness Measurement BoF, please send us your interest so you'll be a next speaker in Fukuoka. Thank you. Okay, so the next speaker is John Brozovic from Comcast. He is actually joining from east coast of US. It's 3:40 a.m. for his time. Thank you, John. Again, you ready? Okay, John, the floor is yours.
Hello?
Hello, we've got you.
Yes, we can hear you.
MIWA, good morning, how are you?
Thank you, we can hear you very clearly.
Okay. You sure the sound is okay?
Yes.
Okay, great. Could you go to the next slide, please? So one of the things that I want to share with you as part of this particular, this session is a bit of an extension, some more details around some of the measurements that we conduct from a V6 point of view. You'll notice here on the screen that we have on the top part of the slide we have V6 round trip or round trip times RTTs, and on the bottom we have V4. For those folks that were present during the plenary, we kind of made mention of some of these measurements at a very high level. As Comcast goes down the path of expanding its deployment, but also really kind of looking into deploying devices that are V6 only, it's obviously very important that we have is V6 performing at the Comcast network, within the Comcast network, and also to the internet, which you'll see here on this slide comparison of some of our of what we see as V6 round trip time compared to V4. Summarized, what we've done is we have measurements that go out from our regional networks out to various destinations on the internet. So what you'll see here is some averages of performance from our network out to the internet. You'll notice that and I don't know if I can kind of control the mouse or not, but you'll notice that in the upper graph, you'll see that there's a pink line, and you'll notice that there's a spike.
Hey, John, can you just stop it? Everybody, John's slide is already uploaded onto website, so you can download and open it. John, if you want to do the your screen share, you can do that, but I don't want to disturb you too much, so.
Yeah, I can do that. It's no problem, y'all.
Okay, okay.
Can you guys see my screen?
Yes, clear.
Perfect. Okay, you'll notice here, in this area in particular, you'll notice that there is a corresponding spike in round trip time for v4. Generally speaking, what we're looking for when we conduct measurements like these is we're looking for areas where these are out of sync or where we see an anomaly in one IP version or another. In this case in particular, this is an indicator for us that that perhaps there was something kind of universally happening, heading to a certain destination on the internet. What you'll see in cases like the one below, where you see this blue line, in some cases when we see kind of a mismatch in these values, it sometimes means that it's something internally on our end where we've had a maintenance activity that affected one version of IP over another. I want to proceed to the next slide, and you'll see in this case in particular for this measurement data set for the central part of the United States, you'll see that this area in the top where this brown graph is, or this brown line is, this was a pretty clear indication that for this particular time frame and for these destinations on the internet, we had a maintenance activity that affected our that affected the round trip times, and it was actually pretty obvious. And this looks like something that was on our end from a maintenance point of view. So maybe we had a maintenance that was intended to be a dual stack maintenance, but perhaps the v4 configuration did not get corrected or applied at the same time as the v4 ones did. I won't kind of go through all these in detail, but you'll notice that for each of these examples, that there are kind of differences in some cases differences in behavior, but in many cases, many of them are very kind of identical from a performance point of view. This slide here in particular for the western part of the U.S. during the same time frame, the black line is nearly identical compared to the for v4 and v6. Before I move on to some of the traffic, are there any questions as it relates to some of that round trip time measurement, for some of the round trip time measurements? Okay. As also just kind of a recap, as I mentioned earlier during the plenary, we also have experienced an enormous amount of growth in our V6 traffic. Over an 8-month period of time, we've seen 50 times growth in kind of internet-facing IPv6 traffic. It's a very positive sign. However, it is important to note that while we're seeing extraordinary growth in V6 traffic, we still have a tremendous amount of IPv4 only traffic that remains in the network today, facing the internet. And we'd love nothing more than to see this trend to continue. I'd love to come back and share information with this group, maybe a year from now, and I'd love to be able to tell you that we've had another 50 times growth. That would be absolutely extraordinary. So just to kind of give you some insight into some of the measurements that we are exploring in the future, because a V6 only experience is very important. Some of the things that we are, looking at doing to kind of extend and improve our measurements. If you guys recall, during during the plenary with Jeff, he mentioned that, regionally, how people get to various, content on the internet, how they get there, it differs dramatically, right? So how I get to Google in the United States from Philadelphia differs from how maybe some people get to Google or other sites in California or even in Australia. So some of the things that we're looking at doing is really kind of measuring a view of the most popular content for the Comcast network. We'll call it, maybe our measured view of the Alexa or maybe perhaps the Comcast Top X. So I'm sure everybody in the room is familiar with the Alexa Top 1000. And while many of those websites are in fact very popular on the Comcast network, they're not identical, right? So there are certainly websites that are in the Alexa Top 1000 that may not be in what I call the Comcast Top 1000. So what we're in the process of doing is really kind of expanding and exploring kind of deeper, more kind of contextually relevant measurements from our network out to the internet. And in some cases that includes kind of measuring V6 performance for websites that are the most popular in the Comcast subscribers. And one of the things that we are also doing as an extension on that front is really kind of measuring the what we're calling the IPv6 only index. So today, many of the measurements simply go out and look at www.example.com, but we don't often look at the reachability over V6 for many of the embedded URLs within a single page. So, for example, even for websites that we have out there on the internet for Comcast, not every embedded link is one that is hosted by Comcast. So what we are in the process of doing is, in an automated fashion, really taking the notion of measurements to another level and assessing what percentage of some of these most popular destinations on the internet is really available over IPv6. So today, if you were to turn off your IPv4 and really, try to utilize IPv6 to go to very popular websites, whether it be Google or Facebook or even Comcast, it's important to understand what percentage of that page's experience is available over IPv6 only. Two very important examples from our perspective around what we're trying to do to really understand what how pervasive support for V6 is. And finally, one of the things that I'll make note of here is we're finding that the more that we share this information with people, that the more that we learn that there's interest in people having available our measurement information publicly available, right? So if you look at the great work that's done by Jeff and his team at APNIC, it's all available on off of your main website. We're also looking at deploying a kind of a measurement portal off of our main information website, comcast6.net, called measurements.comcast6.net. So hopefully, throughout the latter part of this year, early next, we'll be able to kind of make this available, to folks around the world, so that people can see some of this information that we're collecting. So Miwa, back to you.
Hi, John. It's Michael Barber. I'll be Miwa's here, but I'll be taking it through. Are there any questions for John at the moment? I'm just looking around the room. Yes, we do have a question. Somebody's coming. George. It's Eric. Yep. Eric.
Hi, John. This is Eric Vinke from Cisco. First of all, congratulations to stay so late during the night. Now I see that your IPv6 traffic is growing. Of course, you are adding more and more CMTS with IPv6 enabled, so that's to be expected. But do you have a measure about the ratio about IPv4 versus IPv6 on IPv6 enabled CMTS? Assuming there are more and more. For instance, LinkedIn has just been IPv6 enabled, so a little bit more traffic and so on and so on.
Yep. So Eric, every CMTS on the Comcast network as of this past April, has been enabled with full support for IPv6. So there's not a single customer serving CMTS on the Comcast network that is not fully V6 enabled as of April of this year. One of the key things that is remaining from our perspective is, so many people hear that and they say to me, wow, so John, you have V6 enabled for all of your customers. And they're not really the same, it's not really the same answer, Eric. So we have every CMTS enabled with V6 today, but one of the important tasks that we have outstanding at this stage of the game is to enable the customer CPE. So on the panel that you and I were on earlier today, I mentioned to folks that we have 30% of our customers are actively provisioned with native dual stack connectivity. So and really what that means is there's an intersection between the customer CPE and the fact that we have every CMTS enabled on the Comcast footprint. So 100% of our CMTSs are in fact V6 enabled. And really kind of the portion of this that is kind of recurring or ongoing is the fact that we can remotely push software updates and configuration updates to enable the CPEs that our customers use, particularly the ones that are provided by Comcast, to also support IPv6.
Okay, but did you see on those specific cable modems or CPE a change in the ratio of IPv4 versus IPv6?
Obviously, we can only observe that once we've enabled IPv6, and it varies, Eric, actually quite a bit, right? So what we've seen in some cases is we see some users, and I'll try to kind of be very clear about this, but we see we do have some measurements around the percentage of V6 traffic that will begin to be utilized once a customer has IPv6 enabled on it. So, for example, we have some customers that are very high users of IPv6, but their overall traffic levels are pretty low. So if you were only using 100 megs a month, which is highly unlikely, we're finding that in some cases like this one, the user is intending to be, is going out of their way to be a V6 only customer, and maybe 90% of their traffic is IPv6. But we find that the average users, once V6 is enabled, maybe has 20% of their traffic going out over V6 on average.
Okay, thank you.
Yep.
Thank you, John. And if there aren't any more questions, actually I had a quick one, but I might send you an email afterwards, just for the sake of time.
Certainly.
If you could join with me in thanking John for his presentation, and also staying for what's been a long day for him. Thank you very much. I'm going to introduce the next speaker, because that's actually me. Okay, so we should have some slides. I'm just going to do a quick Australia update as we go through this, but it will be very quick. One of the reasons it'll be quick is because Australia is actually lagging behind in its IPv6 development compared to most other economies in Asia Pacific, which are going gangbusters and are actually installing it. However, there's some good stories to tell. The issues that arise out of the exhaustion of the IPv4 space has galvanised a lot of people's interest in IPv6 all the way through to end users, residential end users, commercial end users, academia, and all of the ISPs and the members of APNIC. But the next challenges are the enterprise for IPv6 adoption, and not just the internet, which I know is driving all of us at the moment, but also the connection of LANs, the connection of internal routers, the printers, the devices that people actually use in the network that are all IP connected, and of course the Internet of Things, which is gaining great currency. So we're seeing, the traditional exhaustion graphs, and there is a bit of an IPv4 land grab beginning to happen. People are staking claims, collecting v4 addresses, and this is actually having an impact on issues around corporate governance, what will happen with v4 public addresses, and the impact that might have on business continuity. People are beginning to realise that there may be issues around how their businesses will continue to operate. So this post-exhaustion migration issue is something that's actually starting to rear its head in corporate Australia, and we're seeing more and more issues around that. APNIC are doing a lot of work on reclamation of the IPv4 space, so there's a lot happening there. We're seeing IPv4 brokers, both international brokers and homegrown Australian brokers, beginning to emerge. People who are facilitating the transfer of IPv4 addresses between people who have too many and want to give them up and perhaps sell them, and the people who need access to v4 space continuing. So there's a lot of that beginning to happen, and this whole issue around transition mechanisms is something that's beginning to grow. The global, we've seen these graphs all the time, and we'll probably see more of them tonight. I won't spend any time on it, but essentially the global, this is again just the Google space, YouTube, Google, and the service statistics that they provide, but it's reflected in similar statistics from Akamai, the other content service providers, and the various people, Cisco, APNIC, and the others who are actually tracking these global statistics. So, and I'm sure that there'll be some more discussions about this, but essentially the global space is doubling about every 9 months at the moment in terms of IPv4 adoption. We're up to about 4.5%. Some economies, especially in Europe, Belgium, I think, is now the leading IPv6 adopter at something like about 36%. So there's a lot happening there in that space. In Australia, this is again a Google Australian perspective, so this is just Google traffic. They're showing just under 1% at this stage, 0.88%, and that's by international standards, that's actually quite low, that adoption rate, and the people who are actually hitting Google with IPv6 enabled browsers and the various different types of Google content. It is, however, since the last time we met in Malaysia 6 months ago, this has actually doubled. So in 6 months, so the rate of adoption, again from a very low base, but the rate of adoptions is doubling about every 6 months at this point. So one could say, if I was a journalist, I would write an article about how IPv6 adoption in Australia is 50% above the rest of the world, the rate of adoption, but nevertheless that would be misleading. The number of allocated prefixes continue to grow, but there's a big gap between the number of allocated prefixes and the people who are actually advertising them, so the people who are actually doing something with them, and that gap, if anything, is widening at the moment. So there's a lot of people with allocated prefixes. These are the Australian allocated prefixes. All of these slides were updated today, so they're pretty much up to date in terms of the very latest traffic profile statistics, but we're seeing an increasing gap between the people who are actually using these IPv6 transits and the advertised prefixes and the people who've actually acquired them. The same could be said of the graphs that actually come from Venikig.org, which is a terrific site actually, there's a lot of very interesting statistics and graphs. They're showing the website. These are the top 25 websites in Australian sites that are actually hit with IPv6, and this is showing traffic growth doubling about every 52 days at the moment. There is some suggestion it might be plateauing, so it's some interesting statistics to actually watch in the development of that. So it's something that we have to keep an eye on, but that may indicate a problem coming. In Australia, there was initially a very big push from AGIMO, the Australian Government Information Management Office that looks after all the federal government departments. Now there's about 54% IPv6 deployment in production deployment in government departments. It doesn't mean that they're necessarily using it. It does mean that it's there and available to them. But once it's turned on, the same pattern we're seeing in the internet, we're actually seeing in corporate Australia. Once it's turned on, people start to use it. It becomes potentially a protocol of choice. There's a further 23 that are completing by mid-2014, the last time we looked at these stats, they were completing their adoption. One of the interesting things that's skewing the graphs is that since the last election, there's been a dramatic decrease in the number of government departments. So there's a lot of them have actually consolidated, and it's actually had an impact on who's doing V6. So we've got to do some massaging of the data to see if we can continue to actually have a look at that. But we're finding increasingly big government departments, big corporate entities are having IPv6 in their IT governance framework because they're looking at what's actually going to happen to best common practice, and we've actually seen comments from a number of the enterprises that we deal with, seeing that an investment in IPv6 is considered. This is a comment that one of them made, is a small investment in business continuity. It's something to continue to ensure that that the businesses are actually there. We've had a very early history of deployment of IPv6. ARNet3, the Australian Academic Research Network, was one of the first to deploy V6 in a complete production network from 2006. There has been a bit of a slowdown. I'd have to say there's been a bit of a hiatus over the last couple of years in a lot of the rollouts that are actually there. But more and more of the carriers, the large carriers, are developing IPv6 and have actually offered it native. So we've got Internode, which is now part of IONET. Telstra has been offering service for the business-connected customers since September 2011, and that's continuing to roll out for a lot of those services. Optus say, it's hard to get the statistics, but Optus claim, it's Singapore Telecom Optus, claim that they're actually carrying quite a bit of corporate traffic across their backbone and in V6 traffic. So, we can get some words from them. It's difficult to get the statistics. But people like PIPE-TPG, which is now also includes AAPT, are also claiming that they're IPv6 ready. Although it's very interesting when you type IPv6 into their web pages, how many of them have never heard of it. So there's an awful lot of carriers that don't advertise the fact that they're actually doing V6, but we'll see how we go. Jeff Houston, actually talked about, Jeff McClellan, talked about tunnels being an evil thing, but tunnels are sometimes the only way that people can get access to V6, so it's something that we find quite important. We use tunnels in our network to actually supply up to now 35,000 IPv6 tunnel accounts to the student net. 40,000, Kate's telling me, 40,000 now, IPv6 accounts, and that's compound growth over that period. So there's a large number of students who can access. These are the Independent Schools Association who can actually access, and we use these IPv6 tunnels for authentication and services. Thank you. SAGEU, the system, I'm going to finish off in a sec. System Administrators Guild of Australia has actually been conducting IPv6 roadshows, so the industry bodies are starting to actually come up. They did these road shows earlier in the year that our company IPv6 Now was involved in, and they are also offering their members, they have a /32 and they're offering their members /48s to actually get them started in V6 as well. So it's an initiative that the industry groups are actually doing. The AI Group, the Australian Industry Group, which is an industry body that looks after large businesses, actually has IPv6 in their roadmap, so it has profile, it has traction, it's beginning to happen. The Internet of Things is something that's actually developing, and the way forward, we think, is the work, is incorporated in the work that we do with the Asia Pacific IPv6 Task Force, is to share knowledge for people to actually get comfortable about the fact that the way that V6 can actually do that and how we can contribute to best common practice. Thank you. So, are there any questions? No, that was a very quick run through. We'll move on. Thank you. Thanks. Okay.
Next speaker from KISA. Yeah,
Mr.
John.
Mr. John. From KISA is going to give us an update on the Korean IPv6 status.
This is
Thank
the
you.
timer.
Okay.
You click this one.
Okay. Thank you. Yeah. Hello, I'm Yu-Kyung Jung from KISA. I'm happy to present about IPv6 update in this session. In fact, this presentation was prepared by Jin Young, but he couldn't come here, so I present instead of him. Okay. This is our line. Oh, is it two parts?
Just the arrow.
I don't know. Just going? Okay.
Yeah. Okay, it's come up on two. All right.
Okay. First, I'd like to give you an update about our IPv6 readiness. As of August 2014, the Korean was ranked number 9 in the world in terms of obtain IPv6. The preparation rate for the backbone network was 92%, and 65% for the subscribed network, and 16% for the public network. In August 2013, Korean mobile operator LGU Plus launched its IPv6-based voice over LTE service, but the actual service for content, data, and website are yet to be provided. Okay. The Korean government established its first IPv6 transition plan in 2004. They modified twice in 2007 and 2010. However, the commercialization of IPv6-based service have been very poor. The Koreans are not yet using it very much. We think we will be unable to expand its existing service and handle newly creative demands without switching to IPv6. So we established a strategic roadmap to expand the IPv6 to encompass the entirety of network, including all fixed and mobile entities. We analyzed the trouble vector. According to the existing IPv6 transition plan, the rate of network preparation is increasing, but there are some delay in promoting IPv6 support related to various network equipment. In case of provide sector, different participants such as network and service provider and device manufacturer are trying to avoid taking responsibility for introducing IPv6, as they're existing the burden of investment costs such as equipment replacement and software update. They are reluctant to introduce IPv6. In case of public sector, for network equipment, IPv6 service have been mandatorily required since 2008, but website has not been mandated to do so, so there have been a delay. Many companies concerned over security vulnerability of IPv6 and the absence of service model. This is our IPv6 expansion roadmap, which was established in 2014. In 2013, KISA and government have established an IPv6 task force, which was comprised of 13 experts from various fields and held more than 30 meetings for this IPv6 roadmap. Let me give a brief of the roadmap. Our goals are 100% implementation of main IPv6 infrastructure, 100% implementation of backbone network by this year, and 100% implementation of subscribed network by 2017, and launch of first commercial service for wireless and wired internet and website in this year. Execution schedule is as follows. The next page is the execution system. To discuss the political task and issues surrounding introduction of IPv6, the government and industry, academic and research experts are invited to the IPv6 transition strategic discussion board. I think this is the slide is main in this presentation. These slides contain the recent activities according to the IPv6 roadmap. First, we revised the special tax treatment for tax deduction on IPv6 equipment on March in this year. A certain portion of the cost of purchasing IPv6 equipment should be tax deductible to reduce the burden on any company introducing IPv6. And second, we are processing mandatory introduction of IPv6 by the government and public organization. According to the National Informatization Framework Act to be newly revised in 2015, the government and public organizations, network and website must introduce and use IPv6 so as to support its use among the private sector. Third, we provide commercialized professional training, technical consulting, and guide for the small and medium company to support them. For your reference, the KIPO, Korean Intellectual Property Office, has applied for the IPv6 transition consulting to KISA recently. KIPO's decision to adopt IPv6 system was triggered by U.S. Patent Trademark Office plan to implement IPv6 system by September in this year, which was based on U.S. federal government IPv6 transition policy. This case showed that the IPv6 diffusion of government policy of individual country is also affecting IPv6 diffusion of other country. It indicated that the role of the government and corporation among them is important for the IPv6 transition and expansion. And now I introduce my work for IPv6. First, I conduct research of security products like firewall on IPv6 network. It is the first step of research. Our goal is to list off the factors what security product should have to work on IPv6 network. Second, KISA formed a consultative group that consists of domestic industry like ISP and content provider and manufacturer. It is a small and closing meeting for 10 members who are manager of major company on each area and KISA and government. I managed the schedule the meeting once on 2 or 3 months. We share the status and check progress of IPv6 roadmap. And KISA tried to solve the problem which discussed in meeting and encouraging the amazing company to lead the IPv6 transition of domestic business. As a result, I have a news from KISA in this morning. SK Telecom, major mobile operator in Korea, is planning to launch IPv6-based commercial service with Samsung cell phone. You know the Samsung Note 4 in October in this year. And Samsung Note 4, I heard it is for IPv6 only terminal. Also, Daum, major content provider, is planning to launch IPv6-based portal website also. By publishing IPv6 roadmap and launching IPv6 commercial service this year, we expect to accelerate the IPv6 transition in Korea. And KISA is able to make communication between government and industry, and we can support the relation of other country and international government organization. We think that is the role of KISA as well as the operating the IP system. For example, a month ago, my boss visited T-Mobile with SKT member before providing commercial service. And KISA asked APNIC and to help to contact T-Mobile. KISA will continuously cooperating and exchange with other countries for the development of IPv6. Here's the end of my presentation. Thank you.
Thank you. Are there any questions? Just a moment. It's interesting. We've got a lot of speakers to go through, so people, and the slides will be available on the APNIC site. So I know most of you would have had difficulty reading those, but they're certainly available to you. Well, thank you. It's a present for you. Thank you very much for speaking. Thanks. Okay, our next speaker is from Vietnam, Nguyen Trong Giang. Is he here? Yes, he is. Very good. Hello. Come on down. Come on down, actually. It's a bit like a game show. Thank you. We're going to try and keep to 9 minutes for each of the speakers, so we'll see how we go.
Hello, everyone. My name is Giang from APNIC. We are, after that, I will update some information about the information update deployment in IPv6 in Vietnam. The information I present in this content includes three main content: is nation IPv6 master plan and Vietnam IPv6 readiness management, Vietnam IPv6 ready logo project. In Vietnam, we have a nation IPv6 action plan. In Vietnam, we have three phases with preparation stage, implementation phase, and accomplishment phase. According to preparation stage from 2011 and to 2012, we made the assessment of the network, forming the nation IPv6 test network, implementation of IPv6 test, and performance extensive training of human resource. As a content, we are Vietnam ISP shall use their own IPv6 action plan, follow-on nation plan on IPv6. Now we are on implementation phase. It's from 2013 to 2015. We are transition from IPv6 network to us simultaneously support IPv6 and IPv4 and IPv6, forming nation IPv6 network infrastructure and provide testing IPv6 service to end user. In next phase, accomplishment from 2016 and to 2019, we are ensure the stable operation of internet in Vietnam with IPv6-based technology. In this year, we have a Vietnam IPv6 Day. It's in this IPv6 Day. We have a name is IPv6 Showcase. In this conference, we have how with Vietnam IPv6 Day set to 6 May yearly. Vietnam IPv6 Day conference have a work, we have a workshop with content certified network program IPv6 from in this conference. Is going to have a lot of participants is with more than 300 and monitor in IPv6 even in Vietnam 2014. With Vietnam IPv6 readiness measurement, we have 43 local ISP and CP participants in with 3 ISP with full city criteria ready and 6 other with 10 criteria ready. With the APNIC registry system, we have deployed in IPMS, IP management system, and DMS, the system, domain management system. We are deploying monitor on Readiness network, nation DNet network, and VNIX. We are collection information from other organizations, example ISP and enterprise. In the IPv6 penetration in measured by Google, you can see the, here recognized in some conference we are held is present in measured by Google. With IPv6 network in Vietnam, we have Vietnam Nation IPv6 network is included in Nation DNet network, VNIX network, and other ICP network. Vietnam Nation DNet, we have 3 DNet support IPv6. And in Vietnam now have 10 ISP connect to VNX with dual stack IPv6 and IPv4. With international IPv6 connectivity, we have 4 ISP connect to another upstream provider to international connection. In local, we have deployed some tunnel broker with remark the net name over 2,000 tunnel, 20,000 tunnel have increased. With DNS server, we have with AA query, we have over 17% to query with DNS. In this year, we are prepared to project to build lab to making test specification and approve lab with IPv6 forum. We have cooperation with the committee to deploy IPv6 ready logo program. It's maybe in early 2050 we are run and certified for some company and service in ISV in Vietnam, example website and other application in some enterprise in Vietnam. Yeah, thank you.
Very good. Are there any questions from our colleagues from Vietnam? They're doing wonderful work, actually, so it's very good. It's good to see the progress that's being made in the last couple of years. It's terrific. So thank you very much for speaking. Thank you. Thank you. It's good to have you. Thanks a lot. Our next speaker, who's already been on today, Shishir, is here he comes, from Cisco Systems, is going to talk to us about ULA network experience. ULA is an interesting topic. Shishir, thank you for joining us.
Okay, my name is Shishio Tsuchiya, consulting systems engineer at Cisco Systems Japan. I will presentation ULA network experience at Januk 34. This is the agenda. I'd like to explain what is ULA and what it should work. And after that, I will explain the Janong 34 experience. What is ULA? Unique local IPv6 unicast address, local address which is defined by the RFC 4193. They use FC00 and FT00. And local bit 1 is FT00, locally assigned global unique ID by randomly. This is sample of a global ID assignment. Please check the URL if you are interested in. How it should work, multi-prefix with GUA. This figure access provider providing some walled garden services such as video and voice. And also they're providing IPv4 and IPv6 internet. Then the terminal has 3 types of address. One is a v4 private address, another is a v6 global address, and also they have a ULA address. In that case, communication in the walled garden services, they should be use ULA address, and to IPv4 only global site, then they have to use IPv4. And to IPv4, IPv6 dual stack global site, then they have to use GUA address. The behavior is defined RFC 6724. This type is UL only IPv6. This service is not providing IPv6 internet, and this type is a terminal has 2 types. Communication with walled garden services, they have to use ULA, and to IPv4 only global site, they have to use IPv4, and to dual stack global site, then they have to IPv4. This is a ULA only network. They have only IPv6 ULA address. In this case, communication within the walled garden, they have to use a ULA address, and to IPv4 only global site, then the terminal should need NAT64. And to IPv4, IPv6 global site, they will use NAT66. So why I'd like to test ULA at Janong 34. RFC 6724 default address selection for IPv6 was requested by the Matsumoto-san, who worked at NTT R&D. It comes from the NTT IPv6 deployment experience. And the draft IETF-v6 Ops ULA usage recommendation is now working group document, but operation experience is not enough. So we test it. And next is the Janong 34 experience, which is tested by the Ohara-san. About Janong, Janong is a Japan Network Operation Group, a meeting held 3 times a year. We had Janong 34, which is held at Takamatsu City, Kagawa Prefecture. 547 participants, and stream reach 270 at maximum. Mainly tested by the Ohara-san Mac laptop, and the conference network is served by the only one physical PC and VM and virtual software. The peak traffic is approximately 140 megabps for IPv4 and 40 megabps for IPv6. This is logical network topology, and this is logical network topology. We had 2 SSID for ULA testing. One is ULA only testing, another is ULA and GUA and IPv4 testing. This is detailed information about ULA plus GUA plus IPv4 segment. ULA, GUA, private IPv4 address are distributed by Slack and DHCP. DHCP-v6 is used to inform the DNS server. Even ULA address are translated to the GUA by stateless prefix NAT. Obara-san tested many applications. Most of the applications are okay, and they also check connectivity to the IPv4 only site and dual stack site. Then most of the applications, all of the testing is succeeded. But no communication happened using ULA because we did not provide any ULA only, conference only application. And this is a detailed address assignment ULA, GUA, IPv4 segment. And this terminal has IPv6 link local and also IPv4 private address. And they have a Slack GUA address and the Slack GUA privacy extension and the Slack ULA address and the Slack ULA privacy extension. Yeah, this is a ULA only segment network detailed information. Only ULA address are distributed by both Slack and DHCP-v6. And this terminal no IPv4 address. Some application is okay, and IPv4 only site and dual stack global site is connectivity okay, but some IPv4 only application, such as Skype, is not good. This is ULA only segment terminal information, the IPv4 link local, and Slack ULA privacy extension, DHCP-v6 ULA, and IPv4 link local address. This is a communications sequence over from ULA only to IPv4 only site. IPv6 address Slack and DHCP-v6, and they like to connect to the IPv4 site. Then the DNS6.4 work, and they also use DNS6.4 well-known addresses. Then the NAT6.4 translate by the well-known address to the global address. This is okay. This is a test result summary. Adding ULA to GUA plus IPv4 seemed harmless. Coexistence of Slack ULA, DHCP-v6 ULA, stateless prefix NAT66, and stateless DNS6.0 NAT6.0 in a segment is possible. Android did not bring the NIC up without IPv4 address. IPv4 only application. Skype did not work in the ULA only, and Dropbox wouldn't neither, and not tested either. This application is not tested. My presentation ended, and I'd like to thank to the Shinichi Okubo, Kazuki Shimizu, and Janok 34 LA team who made the Janok 34 conference network, and Yasuhiko Ohara, who tested Janok 34 ULA network and reported to the result to the IETF-90. And I'd like to also I'd also thank to the Janok 34 participant. My presentation ended. Thank you for your attention.
Are there any questions? We have one quick question. Sonny. Okay. Have to be quick.
Is that good? Yep, yeah. Good. What kind of devices were you using for the tests? What device were you using?
Mac laptop.
Sorry?
Mainly, we use the Mac laptop and Android. Are you asking Android terminal?
I'm wondering, well, for your results,
yeah.
Especially for Skype, whether the results would have changed if you had 464xCloud installed, because that would have altered the results. and you would have seen Skype, for example, working.
Yeah.
So if it was a combination of 464xlat plus ULA,
Yeah.
your results might be different.
Yeah.
So I'll be interested if what results you would get if that was a scenario.
Okay. Actually, I'm not tested, so I'd like to inform the detailed information to you. Please exchange a business card.
Yep, absolutely, absolutely. It's possible. It's possible.
Yeah.
And of course, not at the other side of right. So,
Yes.
just to make the picture more complex, actually, the most of the result you got was not by using ULA,
Yeah.
was by using IPv6 only SSID. Am I right? So the last point
Yeah.
was not so much about using ULA only.
Yep.
It was about using IPv6 only SSID.
IPv6 GUA only? No.
No, if you were using IPv6 GUA
Yeah.
only, I would
yeah.
guess you will get the same result
Yes.
as a ULA only.
Yes, you are
Okay.
correct. It should be same result.
Okay, thank you.
Thank you very much.
Thank you. Thank you. Thank you very much. Please thank all of our speakers. That actually is the end of the Asia Pacific Task Force section for tonight. I'd like to invite Dr. Teng to come up. She is the chair of the IPv6 Readiness BoF. Jing. Okay. I should be taking up.
Good evening, ladies and gentlemen. Welcome to IPv6 Readiness Measurement BoF. My name is Ai-Ching Lu from APNIC. The chair of the BoF, Professor Zheng, he cannot attend the meeting, so I'm here today on behalf of him to chair the BoF. Yeah, I think before we start, may I have a slide? Yeah, before we start, I think let me give you a quick recap the BoF status. Yeah, until now, I think that we have two BoF. The first BoF on last year on August at APNIC 36. In the meeting, we discussed methodology of readiness measurement. And we also invite some speakers from different organizations to share some information with us. After that, we created a mail list and built a website, and we classify different measurement criteria. And we also have the measurement workshop with Global IPv6 Summit in Taiwan. Then the second BoF meeting on this year, February. Yeah, this time we proposed 3 common criteria. The first criteria is IPv6 allocation and the BGP advertisement. I think the source data is from the REP NCC. The second criteria is user availability. We propose to use the Google and the APNIC data. Third criteria is service availability. We propose to use the DNS record of each CCTLD to check the IPv6 availability of web, DNS, and the mail. Then later, we do some post-processing for these 3 common criteria. I think that including the data acquisition, data analysis, and data virtualization. And we put some outcome on our website, so if somebody have an interest in this topic, maybe you can visit our website. And we also want to help the CCTLD to check the IPv6 availability. We developed an IPv6-enabled server detection tool. We hope the CTLD can easy to submit the data to us. And in the past year, we have 16 organizations to participate in our major events. And here I will thanks for your contribution. Now let me take a look at the 3 common measurement criteria. And from this graph, we can see the JP and the SG Singapore and MY. I think they is on the top 3 within the 30 countries of the AP region. Yeah, in the first criteria and the second criteria. And this is the other criteria is service availability. And you can see only 4 CCTLD registry provide the data. We think for the service availability, this part, it is not easy to get the data. So I mentioned previous, that is why we developed an IPv6 enabled server detection tool to help them. But we invited 16 CCTLD, including the 7 NIR, and they think some registry think maybe now is the right time to publish the data. I think they still have some concern for this one. Yeah, so I think we have some issues for the data collection, but I think somehow we will find out another way to face this question. And today, I think that we invite 6 speakers to the BoF meeting. So we think we want to get more information and to share the information with them. And we hope we can get more appropriate methodology of measurement, especially in the service availability. Okay, so I think now we want to invite the first speakers, George Michelson from APNIC.
Hello everyone. Hello everyone. I'll try and be as quick as I can. So we have been engaged in a long-term measurement for 3 years more of end-user capability. We can't measure bandwidth at exchanges. We can't measure how many packets flow inside anyone's own network. We can't measure DNS capabilities directly from the head end. We measure end users. That's what we have. So we've got a system that we're using based around Flash placements in an advertising channel in JavaScript directly in websites. And we select users at random worldwide. We're getting somewhere around 300,000 to 400,000 measurements per day for a fairly low cost. And what we're doing is sending pixels that never get displayed to the user, but they show us what happened in the DNS and in the web. We configure the DNS name that actually leads to the web server, and we run the server behind that name. So we get to see all the packets that go to the DNS and all the packets that come to the web. And we can collate these together. Down the bottom of the page, you can see an example of the kind of names that we're getting people to fetch from. And this encodes some uniqueness to guarantee that no one else has seen them, and it encodes different qualities that are expressed in terms of the mapping from the name to IPv4 or IPv6 or a dual stack. So we get to see if the DNS the client is using is able to manage v4 only, v6 only, and dual stack DNS. We're able to measure that. And we get to see if the web client, the actual user, is able to do a v4 only fetch, a v6 only fetch, or a dual stack fetch. And we get some sense of the behavior under happy eyeballs of what people are doing when they're faced with a dual stack request. And we can correlate this with the resolver. We also do other things. We measure DNSSEC behavior in the same system. So this year, what we've done is we've taken all of that data and we've put it into an SQL system. We thought it was time to catch up with modern technology. And we have also adopted a self-consistent charting methodology that we use in both DNSSEC and v6 and also in BGP. So if you see any of the results that we're doing, they look really very consistent. The other thing that I haven't put on this slide is that we saw what Eric was doing, Eric Vinke's website was doing with the timeline, and we liked it so much, we stole it. So all of our data is published at a single point, stats.labs.apnic.net, and you can see breakdowns by region. We chose the UN reporting regions because these are things that people outside of our space can use for strategic planning. It helps to reflect on what regulators, economic planners, people work with, and they like the UN reporting regions. We publish by economy, and we also publish by autonomous system number, which in effect is the ISPs within a given economy and also individually. And we've got a scripting form of fetching these URLs that we think should be very easy for people to use themselves. So if you like what you're seeing here, if you want to fetch the data and reflect on it, it's really easy to get a different AS for comparison or a different economy for comparison or add and remove elements of the graph. We thought we'd make it a general tool that could be built on. Here's a typical example. This is the current state as of yesterday of the world. This one's been smoothed to a 10-day average figure, so it's got rid of a lot of the variability in the daily sample. And you can see that it's actually up somewhere around 1.9 to 2%. There was a bug in the y-axis charting that we've fixed since then. I should have updated the slide pack. Now, that figure is quite a lot less than the Google figure that Mike showed you earlier on his chart. We are actually quite aware of the fact that we now count less than some of the other measures that you're used to seeing. And we've reflected on this for quite a long time. Why is it that we think we see less? And I'm going to talk about that later in the presentation. You can also see that we're providing some tabular breakdowns of the regional structure. So when you look at this view, you can see the world's at around 2, but the Americas are up at 4.5. Europe's at 3.9, Oceania at just under 1%. So we have mapping using the Google chart. This is the Asian map, so it runs between 0 and 6%. You can get a sense of which economies are doing activity in V6. And within the regions, we provide a similar chart of the rundown, and the ranking here of the first 15 is our rough sense of where the Asia footprint is in V6. And you can see that some economies, like Singapore and Japan, are running well ahead of the world's current level as we measure it. So there's people in our region who are doing better than we see the world on average. There's Malaysia on 3%, and then there's Bhutan on 1.39, China on 0.8. So we also have a spread of economies in region which are doing under the world's best level. And you know, there's kind of a story there that this one-line statement, the world is on 2% or the world is on 4%, that isn't actually a really good summary of where the world is, because the world is quite different. Different economic forces apply in different economies. Where people are in their rate of V6 adoption isn't informed by what the world is doing so much as what their local economy does and the conditions they face for deploying their network. So within an economy, this is Singapore, we can provide the ranking and breakdown by AS. Now, you can see that some distortions creep in here. If you look right over on the right-hand side, you see the sample count. So the top ranking sample there is Sony. Well, the Sony office in Singapore is 100% V6 enabled, but we only saw 57. That's not contributing a lot to the overall count in Singapore. But if you look down, you start to see that there are real providers like One Asia Host that are on 23%, and critically StarHub, who are sitting on 22% with 6,000 samples. That's much more indicative of a real ISP's service in the economy. And they actually appear to have done a quite significant deployment. I think if you look on our charts or on Eric's charts, you can see a really rapid ramp when this deployment goes live. It actually peaked quite a bit higher and dropped off again. We suspect that they did some post-deployment adjustments and it reduced some of the overall availability, but it's quite nice to look at. Okay, so what's my sense of what's driving this? Well, the answer is that you guys, the people who actually do network deployment, are the ones who drive it. You get to decide the pace based on what you can achieve, but this has qualities of limits. It's about the rate of things like the CPE. So when we heard that in Korea there's been a decision to provide a 7% tax break for a small company and a 3% tax break for a large company, that's a phenomenally significant outcome. We have this thing where people talk about regulators as if all they do is hit people with sticks, but regulators always have a carrot and a stick. And if you can offer in your own economy a neutral position for everyone to reinvest and get round a problem like old CPE, the chances are it's going to have some effect. So that's a very interesting outcome. My personal feeling is that the fundamentals here aren't really about problems in the technology. I'm sure there are problems and reasons why people choose not to deploy relating to things they don't like in the protocol, but essentially it's about a business investment decision. That's really what it comes down to. So why is it that our measurements aren't necessarily agreeing with other people? Well, the first thing is we really exclusively measure the end user capability. We have this large random sample set, but we do know that we're not picking up mobile devices, and we think some other people have a different number because they actually see into the mobile handset. We know this is an issue, and we've been trying to work on ways to get around this. There is this factor that some of the other measures in the IPv6 task force reflect on other qualities like capacity and bandwidth and inter-provider stuff. We just don't measure in that space. So when you guys see an upswing that's about traffic at an exchange point, that doesn't necessarily reflect anything that we would see at an end user level. There might be a number of things happening off exchange, like Facebook providing an in-provider hub or a Google hub, and that's not going to be visible necessarily in all measures. So there are things that we're going to see that other people don't see, and vice versa. The other thing is that after some discussion and review, we actually started applying a population adjustment to our world ranking. We looked at the way we were collecting data and saw that we had quite a lot of skew emerging from perhaps Indonesia or China, where there was a lot of advertising presentation. So we had a lot of samples coming from these economies. And when we put the ITU data, which has been published every year, back into the mix and adjusted our relativities by the population of internet users, Jeff's actually done some quite nice work to do a birth rate increase. So we get the beginning of year rate of the population, and then we do an adjustment on that. I was absolutely fascinated by this statement yesterday that in China they're seeing, actually no, it was earlier today, that they see 640 million users in China, because the ITU figure is actually more like 540. So they've got 100 million users that aren't currently being accounted for, which is quite interesting. But that adjustment actually has a huge impact on our sense of world uptake. And we think some of the more popular charts that we're looking at haven't got that class of adjustment. So the reason we sit by 2 to 2.5% as our figure is that we've done an adjustment to account for population, and we think that may be accounting for some of the statistical differences. So if you want to look at our data, everything's made available from this URL. Thank you.
Does anyone have any question? No? Okay, now let's welcome the next speaker from the SGNIC. Come on, okay?
Okay, good evening, everyone. I am Mon, consultant at Singapore Network Information, which is the CCTLD operator for .sg domain names. So now I'm going to present about measuring IPv6 adoption from a CCTLD perspective. So a little background about why we're doing this thing. So first, SGNIC is a wholly owned subsidiary of the government. So the government wanted to see the IPv6 adoption through all the government agencies. So they thought of why not have SGNIC gather some of these statistics and then present it to them. So that's one of the reasons. And then another thing is, since we have a database of all .sg domain names, we're quite curious on what the IPv6 adoption is from the domain space level. So let's see. Okay, so what is the, okay, thank you. So what is the goal? So the primary goal is to gather statistics on IPv6 address for all .sg domain names. And then second is to classify active IPv6.sg website into industries. So why do we classify them into industries? We wanted to see whether some of the adoption is driven by specific industries, such as, let's say, manufacturing or the IT industry. So this is the methodology that we use. It's quite simple. Any technical guy can pretty much recreate the script that we did. So first is we dig for any Quad A records for .sg websites. And then we also dig for the quad A records for NS and MX. And then after getting the quad A records, I mean the IPv6 address, we do a telnet of the ports of the common services to check whether a service is active. So for example, for a website, we do a telnet of port 80 and port 443, and then for email, we do a telnet of the SNTP port. And then after getting the number of sites that are active, we do a manual classification of the websites into industries. So these are some of the examples of the industries: professional or business services, or is it a government site? And then furthermore, we also check the country and the net name using the WHOIS database. Okay. So so this is the statistics as of July 2014. So currently we have scanned about 161,800 .sg domain names, and 37,000 of which have IPv6 NS address. 14,800 of which have IPv6 mail address, which 99% are active, and then 2,600 of which are active, have website v6 address, and 83% of which are active. So we do the exercise quarterly. So we started this exercise since 2012. So over here, the graph shows the trend of the active of the domain names with IPv6 address versus how many are active. So a key observation here is the July 2012 data. So we did some research on what could have caused the increase. The increase is actually a 590% increase. So we did some research, and then we realized that in June 2012, it was the World IPv6 launch day, wherein Google turned on IPv6 for some of their services, such as the Google sites. So that could have contributed to this increase. So next is, for the government side, they wanted to see the adoption only for gov.sg domain names. So basically, this is a similar graph from the previous one, except that it only shows gov.sg names. So one key observation here is the increase in IPv6 data in July 2012. So we've asked our colleagues in IDA, which is the government, and they said that the government required agencies to enable IPv6 for their websites from September 2012. So we can quite speculate that during that time, some of the agencies were already testing the deployment of IPv6, and that could have contributed to the increase in July 2012. So this graph shows the industry distribution of active IPv6 website addresses. So one clear observation that we can say from here is that majority of the websites are actually registered by SMEs, meaning professional or business sites, or some of the sites may have been registered for personal use. So we believe that these websites are hosted using third-party or free service providers such as Google sites, which have IPv6 enabled. So that explains why the blue and the red are have a quite big distribution, and then the green is actually because of the government pushing the agencies to adopt IPv6. So furthermore, we wanted to check where are the IPv6 website address located, and who are the companies behind the IPv6 website address. So a clear observation from this graphs is that for IPv6 website addresses located in SG, most are enabled by commercial and government entities. So another observation is that common service providers such as Google services in AU, enabling IPv6 for their website service may account for the high distribution in particular countries. So, to sum up all of our observations and on what we think is the trend of the IPv6 adoption, so we believe that company or individual registrants seem to rely on hosting providers to enable IPv6 for their services. And to us, service providers play a big role in the proliferation of IPv6 websites. So this is evident in when Google turned on IPv6 in some of their services. And then we also saw that some local service providers have enabled IPv6, but not for all of their services. So some may have just enabled it for their name servers. So these are some references which I have used to counter-check our data and to counter-check our data. So that ends my presentation, and I'd be happy to accept any questions.
One question from Miwa, APIPv6 Task Force. Recently, we started observing quite a robust IPv6 readiness in the end users amongst service providers in Singapore. For example, StarHub, StarHub Cable.
Yes, ISP.
Do you see any trend amongst those ISPs who are going through this robust implementation of IPv6 in Singapore?
Let me see. I don't have a straight answer because I never saw any of their report being published. So and also we don't have their data, so I really can't tell on my end. So as far as what we have done, we just wanted to see the IPv6 adoption from a CCTLD perspective. I am quite aware that some are measuring. I mean, it's best to measure from the ISP level, but I haven't spoken with them, so I don't have quite an idea. Okay, thank you.
Yeah. Let's move on to the next speaker, Fujisaki-san from the NTT.
Okay, I see. Hi, good evening. My name is Tomohiro Fujisaki, working for the NTT, and here also is the head of the IPv6 Promotion Council Japan. Okay. Here I'll introduce the Japanese IPv6 measurement. And before that, I'll explain about the IPv6 status in Japan. And from the network point of view, the many fixed-line ISPs started their commercial service, not only for the enterprise users, but also for the consumer users. And many of them provide IPv6 connectivity by default for new users. And some ISPs have started to move their existing IPv4 only customers to the dual stack environment. So in Japan, the number of consumer users are increasing. But however, only a few cellular carriers provide IPv6 connectivity, and they do not provide the IPv6 connectivity by default. This is a network viewpoint. And from the content side, and IPv6 ready government service are increasing. This is a good point, but in Japan, large content providers do not support IPv6 yet. Okay, this is a summary of the current status of IPv6 in Japan. Okay, from the next few slides, I'll explain about IPv6 measurement in Japan, and I show you some measurement from the core network viewpoint, and application viewpoint, access network viewpoint, and users viewpoint, product viewpoint, and the government IPv6 service viewpoint. Okay, the first, maybe many of them see this kind of data many times, but this is the IPv6 allocated prefix in Japan. And as you can see, the number of allocated prefix and announced prefix and active prefix are increasing. And next two graphs show the IPv6 penetration rate in the internet backbone. This means the number of transit areas in Japan. And left graph shows the worldwide average, and the right graph shows the Japanese average. And both graphs increasing, and as you can see, the Japanese average is a little bit higher than the worldwide average from the backbone viewpoint. Okay, the next I'll show you the IPv6 penetration rate in the consumer users. And here, the target service is NTT East and West Internet Access Platform service. And also, for reference, I'll show you some data of the KDDI's IPv6 service and the Chubu Telecommunication Network's IPv6 service. And before that, I'll explain the Japanese IP internet service status. And this graph shows the number of subscribers of fixed line service in Japan, fixed line broadband service in Japan. And as you can see, the fiber service, FTTH service, is 70% of the total service. And in this 70%, the NTT East and West market share is over half of the fiber service. So we, the IPv6 Promotion Council, targeted to measure the IPv6 rate of this NTT East and West service. This table shows the consumer service penetration rate in Japan. And the right percentage shows the percentage of the IPv6 users. And middle of total users of Flex Hikari Next shows the total broadband users in this network. And as you see, the IPv6 users are increasing. And for reference, I show the KDDI and CTC's service, and as you can see, the many users. They have many IPv6 users. For the KDDI case, around 70% users are in the dual stack net environment now. Okay, and this table shows the IPv6 traffic to Google servers. Thank you for Google for providing this graph. And as you can see, the KDDI and CTC is higher IPv6 traffic. Okay, next, I'll explain about the content side. And these two graphs show the IPv6 penetration rate of web servers. And the left graph shows the worldwide average, and the right graph shows the Japanese average. And as you can see, from the content view, penetration rate, IPv6 rate, penetration rate is much lower than the world average in Japan. This is one big problem in Japan. And next graph shows the IPv6 supported .domain servers. And from this graph, you can see that the name servers and mail servers, number of mail servers and DNS servers are increasing, but the web servers are not so increased. Okay, this is last measurement, the IPv6 service readiness in the government servers. And from the, from this URL, you can see the current status of Japanese IPv6 readiness, government servers of IPv6 readiness. And from the data of the 10th September, this September, 44% of web servers and 20% of mail servers and 64% of mail servers are DNS servers are IPv6 ready in the government service. And from this URL, you can see that not only the IPv6 service status, but services, but also the IPv6 service. Not only the servers have IPv6 address, but also the service working good or bad. If you have interest, please visit this URL. Okay, and sorry, this is the last measurement. The number of products with IPv6 ready logo in Japan. And as you can see, the ready logo products increasing, but actually, around the 2004, Japan had many IPv6 ready products, but recently, only few products got the IPv6 ready logo. Okay, this is summary. And in Japan, as you can see, the IPv6 internet users are increasing smoothly, but we have some problems in the cellular service and the content side service. Okay, thank you. Any questions? Okay.
Thank you so much. Next speaker, Jinheng Gu from APNIC.
Good evening, everyone. I'm Jinheng Gu. This is my outline. The first is IPv6 readiness measurement criteria. The second part is the proposed new methodology in service availability. The third one is the conclusions. This slide shows the classification of different measurement criteria. The common criterion has three. The first is IPv6 allocation and the BGP advertisement. The second one is the service availability of CCTLD. The third one is the user availability. Today I will focus on the service availability because to collect the service data from CCTLD has some difficult. So we propose a new methodology in service availability. This method, the data is from the ELISA top 1 million websites. So we have three definitions. The first one is the web availability of CCTLD is the numbers of IPv6 enabled web servers to numbers of CCTLD web servers in ELISA. The second one is the DNS availability. Its ratio is numbers of IPv6 enabled DNS servers to numbers of aggregated CCTLD DN in ELISA. The third one is the emails. What's the aggregated DN domain name? Because we prevent repeating calculating in the DNS and the email-based servers. So all domain names are aggregated to the third level CCTLD to identify the registrants. So since the acquisition of global servers list is nearly impossible, so we use the old list of top 1 million websites released by ELISA, and the categories is web, DNS, and the email. In the following, this slide shows the serviceability on the web availability. Indian have 17.135, and Singapore is 16.196 is top 2. In the DNS servers, the Singapore is the top 1. In the email, the VLAN have 27.88 is the top 1. This data has been shown on the www.ap-v6readiness.org. So the conclusion, we have developed the IPv6 enabled server detection tool for CCTLD registries. But just 4 CCTLD registries have provided the data. In the following, we still encourage CCTLD registry to continually provide their IPv6 service availability data on the BoF platform. And the new methodology of the data acquisition of the third common criterion, the serviceability, based on the list of the 1 million ELISA websites has been proposed. And this is used to observe the trend of the serviceability in the CCTLD. It's on my presentation. Thank you very much. There any problem? Okay, thank you.
So now, welcome next speaker from Cisco, Eric.
Okay, and I will do it very fast and very fast, so I'm speaking fast anyway. So Cisco is running a website regarding the development of IPv6 and the deployment of IPv6. It has been renewed recently, so it's a bit more trendy and it's using more CSS and blah, blah. Basically, the developer behind it is an expert in CSS and JavaScript, so it makes things a bit smoother there. But we may wonder, specifically around 8 p.m., right, whether you prefer blended or single malt. And basically, my point here is that whether we prefer a single IPv6 measurement or we do prefer a blended measurement, pretty much like you are doing in your task force, where you are mixed multiple criteria. And that's what we do in Cisco.com. So we measure the deployment from Google and from APNIC, and they indeed see a difference. But George and Jeff, I prefer yours because it shows 30% for Belgium, and while Google said only 27. So, yeah, thank you so much, right? Tell me where to send the money, right? Anyway, plus all the numbers that we have talked here. You know the story about this Alexa, a list and going there. I would love to bring your attention to one difference, though. There are different kind of measurement on this. For instance, Cisco.com is taking the top 100 per country website accessed by citizens of the country. Meaning, for instance, in Australia, I'm guessing it's Google, and then Facebook, and then Twitter. Okay? But they are not Australian websites. Maybe you have a google.au, but they are not Australian websites. On the other side, what I'm trying to do on my personal website is to look on the TLD and check with the WHOIS database to see who is the owner of the website, which I think is much more sensible. So Google, Facebook, for instance, doesn't count. I think it's much more realistic. We could have even a third way of doing it is where the server is located physically. But who cares if a Singapore website is located in Amazon cloud? I think it's really the websites that are owned by a Singaporean or Australian or whatever. And you see a couple of things that are not always easy. And you are helping me, I don't know whether you still do it, but at some point of time you help me to see whether it's a government, industry, and the like. So important. Again, experiment by yourself. And I was asked as well to show additional value. And one thing I've done, and I'm based in Europe, right? So talking to a couple of European government and task force, is comparing countries. And specifically countries that you are always comparing to. For instance, in Europe, the small countries. Or I'm pretty sure in Australia, you like to be compared to US and other Canada or UK or something like that, because they set the benchmark. It's pretty useful. It's basically leading by the shame, right? I don't show this anymore in the leading countries because that's also bad. Okay? It could put the shame on laggers, but it could also stop the leaders because they are leading. So you know the fable with the turtle and the rabbit, right? So in some cases, it's better to be the turtle. This one, I failed to put the right logo on the top of the slide. Should have been a crystal ball. It's about projection. Once you have the data from whatever source, you can try to project. Most of the thing you can use is quadratic curve. It's kind of nice, very easy to compute. It tends sometimes to show a trend upward, but in some countries, which is something is going down at some point of time, it's show a trend going down. But the thing with the quadratic curve, it's pretty nice when it's small, but it never ends up, right? You will end up with 200% of deployment. Okay, I love quantum computing, but 200% of deployment is tough. So I prefer to use another one, which is the logistic curve, also known the S curve, which starts slowly, but stop basically after S curve, right, and this name, at 100%. It's more about migration. I hope it's more sensible to use it, but the fact is that most of the time, the real IPv6 deployments are for 1 year or 2 years, and I don't think we got enough sample to get a real estimate there. But it's always nice to show. Okay, it was not the last version of the slide deck. I put another slide regarding another way of measuring that you can find on my personal website. BitTorrent for 3 years is dual stack. So every few months, because it's time consuming for me, nothing is automated, I am running for a couple of days a fake BitTorrent client, which is dual stack. And I'm connecting to trackers, right? I download nothing. I only pretend to have the file. So now I see peers worldwide coming back to me over IPv4 and IPv6. That's another way to measure it. Of course, there are rules and laws in some countries that also bias this. Okay, so for instance, Google is not used everywhere, so there is a bias. I'm pretty sure the Google ads are also biased somehow, and the BitTorrent is also biased, but it's pretty good to get a mix of all of this. So go and see. And thank you for your attention. Any questions? But I think it's beaten to death, right? But yeah.
How much BitTorrent is V6?
How much BitTorrent is V6 is something I would say the guess estimate worldwide 10%. So it's more because there is no NAT. Yeah. So I see usually it's kind of unfair to get the ratio of V4, V6 with BitTorrent, because if you are behind the NAT, right, I cannot contact you most of the time. You need to do port forwarding. But most of the V6 implementation I know is no firewall at all. You can contact them. So you are raising the so it's kind of cheating. I mean, you need to know the bias of what you are measuring, basically. But it's big. It's big. Jeff.
So I'm kind of curious, because a lot of the things we measure show underlying patterns and trend. And that seems a bit bizarre to me at times, because these are almost disconnected events. Because my decision to go from V4 to dual stack in ISPA is kind of irrelevant to a decision to go from V4 to dual stack in ISPB in another country. So why is there these visible patterns and trends? And I've kind of looked at this a number of times, and what I think I'm actually measuring, oddly enough, is the momentum of capital and process in the supply industry. We cannot turn on V6 everywhere tomorrow. There's supply chains, there's processes, there's a whole bunch of things that, as every ISP would know, particularly a big ISP, it takes a lot of time to do all the groundwork, to lay things down so that you can eventually start rolling out. And you don't turn it on, you roll it out bit by bit. Why? Because that's the way your processes work. And so we end up, when we measure stuff, measuring process. I'm like, this is the same as the entire internet uptake of 20 years ago. And what you're actually watching was the shift of capital from telephony to IP. In very large companies, it takes a lot of time to shift capital and process. And I suspect we're measuring something that's kind of similar. Mm-hmm. And it's actually about not the technology, it's actually about the supply side mechanics and the inertia of supply side. And that's why these patterns emerge.
And I fully agree. I mean, we should have seen like a Dirac or, you know, the thing in discrete, yeah, which on 97 specification is done, bingo, 100%. We know it's not there. But what is interesting, if you look for very small countries like mine, where we have basically 2 big cable providers, and I think they have in total 5 CMTS. And we see on the curve, ding, ding,
CMTS.
You see
yes.
Really them, and then there's a fluctuation, right?
Yeah. In June, and then you move mid-February on the second one.
Yeah, exactly. And that's something very interesting there. But what is striking as well is that we were before getting kind of an exponential, at least quadratic curve, yep, using Google and your stat. now for the last 6 or 9 months, I see it like linear. The growth is no more increasing. We still, the positive derivative for the deployment, but the second degree derivative is no more there, it's no more positive.
Right, and I suspect if you looked hard enough and
scary.
sideways, you'd find the S-curve has been used in many technologies. I remember seeing the New Yorker doing something about the uptake of the use of washing machines in households across the 20th century, S-curve.
Yeah.
The adoption of televisions in households, S-curve. Because there is this slow, rapid slowing, because saturation takes an awfully long time. And again, this is process and people, it's actually not technology. And that kind of justified in my head why these curves are useful. Because before that I was sort of going, well, it's a curve, but so what? But there is some underlying, I think, economics behind this that actually intrigue me.
Yeah,
and I think it's really cool.
it's the name as well of logistic, right?
Yeah.
Honestly, I learned about this SQF logistic curve about 1 year ago only.
Oh.
And I've got...
Frank Zelensky exposed me to this in 1989 when he said we were going to run out of V4 addresses and fitted an S-curve to the V4 address demand in 1989. It's been around for a while.
Yeah. Anyway, interesting. Thank you. Any other further question? Okay, so let's go back to work and deploy V6, right?
Okay, now welcome the last speakers from Zhonghua Telecom Laboratories, Li Fanwu.
Good evening, everyone. I'm Li Fanwu from Zhonghua Telecom. Okay, thank you. I'm honored to give you a talk at this moment. Today, my topic is Zhonghua Telecom V6 Readiness Update. This slide shows the agenda of my talk. Firstly, I want to introduce the relationship between Taiwan and Zhonghua Telecom. Then I will report the Taiwan business readiness from SP perspective. CST, the acronym for Zhonghua Telecom, is an integrative informational and telecommunication operator in Taiwan. Our major services are providing broadband and mobile communications. Right now, CST is a private company. However, the government is still the major shareholder. From this slide, we can trace the status of V6 routing information during the past few years. It's obvious to see that each RIR has positive growth, AS growth. Taiwan's business ratio is not only matching the trend of the world, but higher than the average ratio in each RIR. With the rise of business traffic, CST has been preparing to respond to the impact from V6. Although there is no immediate benefit to move to V6, business readiness is still an important task for CST. So, if CST can make money from V6, cost reduction might be the first concern. In V4, ISP can just use DHCP-V4 or a Redis server to allocate business addresses. For customer V6 provision, configuring both router and the DHCP-V6 server are necessary. Managing two IP protocols require more than running two network roles. So how to allocate proper number and the size of business prefixes to integrate V4 and the V6 protocols will help reduce the expenses for unnecessary provision management. And operation management is another important issue. Even there are different features between V6 and V4. CST must maintain V6 services as good as V4 services, or our customers will have a better V6 experience and will refuse to use our communication services. In addition, CST's highest cost will spend on technical training. In order to maintain V6 network, CST is still working on how to help educate the operating personnel to develop the basic skills. Another important issue is risk management. Making the right response to handle the rapid increase of V6 traffic is essential, as it may reduce the damage from V6 threats or network service changes. There are two major security concerns. The first concern is protect V6 protocol vulnerabilities in our network. On the other hand, CST must acquire V6 network protection devices. How to harden our network against V6 malicious attacks, and how to design comprehensive test cases to verify the V6 function of network protection devices. This is CST's responsibility to safeguard our network after enabling V6. Besides, LTE brings a new capability to mobile communication. Customers will migrate to 4G in the coming years. LTE technique will create huge address requirement. So how to respond the surge in the new type telecommunication over V6 is a tough question. A consolidated image plan will help CST mitigate the negative impact of network migration. How to leverage our network to create more value is an important goal in CST Future's network roadmap. CST has been have been trying to educate the technical personnel to use V6 to simplify the broadband and the mobile networks. By the power of V6 addressing, V6 can unify all IP-based network. On the other side, in order to make our network more flexible for future services, SDN and NFV techniques are necessary. Our goal is to make our network toward a generic architecture to reduce vendor lock-in and to carry any services. In the future, 10% V6 traffic is our milestone. CST will propose step-by-step plans to deal with the increased V6 traffic. For example, for increased 200% rate from user, CST will monitor the ratio of our V6-enabled communication services. If services can achieve our short-term goal, CST's V6 team will call a meeting to review our V6 upgrade progress and try to find the right action plan to meet the requirement. Besides, CST will keep watching the world-leading ISP's V6 status and adopt their successful V6 policy. In terms of V6 education, CST is working on training technical personnel to get enough V6 skill to manage our network. Thanks for your attention. Any question?
Yeah, I think today we finished both of the section, IPv6 task force and IPv6 readiness measurement, both. Yeah, now I think I appreciated all speakers. I think today you share a lot of information with us. And also I appreciate your attention and the contribution to us. Another way, I think we need to thank you, APNIC's technical team and the hotel's AV staff. I think he assisted a lot and let us the two sections is completely smoothly. Thank you.